All right, in this video, we're going to be looking at composition of functions. Okay, so that's that operation that you don't do with numbers, you just do with functions. And we're going to look at how to do that when we're given graphs, tables, or equations. All right, before we do, though, I want you to kind of see the big difference between composition and combinations to make sense of the difference. It really helps. All right, so let's go back and think about the picture we had for combinations. All right, so you remember how on this one, oops, let me get back to that picture. So you remember how on this one, we had the two functions being next to one another? Okay, so when you're doing the adding, subtracting, multiplying, or dividing, the two functions are next to one another. So you have like the f function and the g function here. X is your input, so x is going to go in. X is going to go through each of those functions, go into each of those functions. Something's going to happen to it, whatever f is. Over here, whatever g is. And then what comes out of the f function, what comes out of the g function, then gets added, subtracted, multiplied, or divided depending upon which one of those you're doing. So if you're doing f plus g and you're trying to understand what f plus g, that new function means, it just means find f of x, find g of x, and when you're finished, you're going to come in here and add those two together. But what comes out at the bottom is f plus g of x. And so we talked about how this illustration shows the two functions are next to one another. You have to make it through each of those, okay? And then you get combined to form the final answer. So f plus minus times or divided by of g just means that you do f of x, you do g of x, and then you perform those operations, whichever one you're illustrating. I just didn't want to have to draw that 4 separate times, okay? Well, I want you to contrast that with this picture, okay? So when you have composition, all right, it's very different. And let me get that to be a little smaller there. And I want you to think about composition. Okay. So what's happening with it is your functions aren't next to one another. Your functions are above one another. So if you're trying to think about what g of f of x would be, let me see if I can make this a little bigger. Okay. The name of this big machine is g of f. Okay. The name of this big machine is the composition of f with g. All right. And then the illustration is going to tell us how it's defined. So what happens is your input is going to go into the big machine. Okay, when it does, that x value is going to go into the first function. And in this case, the first function will be f. Then whatever f is, whatever process that is, that happens to x. Well, you know what comes out of the f function, what comes out there is going to be f of x. Now, here's the big difference between composition and combination. So listen to this. X does not go into the g function. Okay, x goes into f. F of x, what comes out of f, goes into the g function. So these two functions are above one another, okay? They're not next to one another, okay? This is like they're in series rather than parallel, okay? If you think about electricity, that kind of holds true there as well, all right? So f of x is going to go into the g function, something's going to happen, and what comes out the other end of that would be g of your input. So the input was f of x, so g of f of x is what comes out of that one. All right, and so the overall machine was called g of the composition of g with f, and so what comes out at the end is this. And so that means these two things better be equal. That defines what the composition of g with f would be. It just means this. Okay. All right. And then I really harped on you understanding function notation so that when you see something like that, g of f of x, you can just do what it says. Okay. All right, now, if we look at switching the F and the G around and doing the composition of F with G, you can imagine what happens there. It just reverses order. G is first, F is second. I won't finish it here, but I'll post an illustration later for you, okay? All right, let's go ahead and make use of this concept. Let's go to the worksheet on combinations and try a few of these. And let's go ahead and start with the equations like we did before, okay? So I'm trying to do the composition of G with F of 7, okay? So first I want to think about its meaning. That's what it means. Notice that they were in the same order, remember, when we were looking at that picture, okay? They were in the same order. So if it was G, composition of G with F, then it was G of F of X, okay? All right. So then we just do what that says. So we start with the innermost parenthesis, the 7, and we do F of 7. And these would be better done, okay, with it up and down rather than horizontally. So let me see if I can just go ahead and get some more paper here, okay, and get it to be next to it. Multiple pages, and I kind of want it to be this one up here. Let me go back to one page. It's not really going to do what I want. All right, so let me just do it horizontally, but you just let's see if you can make sense of it with me. So F of 7, that would be putting 7 in there. So F of 7, this part would be square root of 9. So I might want to go ahead and reduce that. That would be 3. And then don't forget, you need to do G of that. So now I do G of 3. So I come over here and I say, okay, that's going to be negative 1 over 3. Okay. All right, if I did G of F of negative 7, how would that affect things? All right, I'm going to plug negative 7 into the F function. When I do that, I wind up getting the square root of negative 5, which is not a real number, okay? So that's kind of like not in the real number system. It's sort of undefined. And so right there, I would just say this is undefined. If you put a negative 7 in to the F function, you know, that first function, it gets stuck and nothing comes out. So you don't have anything to put into G, okay? All right, what about this one? F of, this flipped around now. This is F of G of negative 1, 7. So let's see what happens there. Okay, so we start with G and we put in a negative 1/7 into G. So G says do negative 1 over your input. Okay. And then that 1 divided by negative 1/7. Let me do a little sub problem over here. That would equal 1 times, you know, keep, change, flip, a negative 7 over 1. So this part right here would be a negative 7. And so we really then need to do F of 7. That was a little tricky, so you might want to think about that carefully. So simplifying that negative 1 over a negative 1/7 turns out to be positive 7. But I need F of that, so I put 7 into the F function, and I get square root of 9, and then simplifying that, I would have just 3. Okay. All right, what about putting a 0 in? And what if we put a 0 in this way? G of F of 0. So the 0 goes into the F function first. So that'll give me square root of 2. And then I need negative 1 over the square root of 2. That's basically your answer. Sometimes they ask for you to rationalize denominators. And so that would be when you would come in and multiply by the square root of 2 over square root of 2. And then these two would become just 2. I would have taken negative 1 over the square root of 2. But I just wanted to mention that. All right, and then if you did F of G of 0, g of 0 is a problem. Okay, when you do g of 0, try to do it, you get a 0 in the denominator that's undefined. This whole thing is undefined. If you put a 0 into the g function, you don't come out the other end. Okay, so there's no way then to finish the problem. It's just undefined. Okay. All right, and then I wanted you to know that you could do g of something, that you could use a function and compose it with itself. So g of 5 in the g function, that would be -1 over my input. Okay, and then g of that would be a -1 over my input. Okay, and that's a lot like something we did earlier. So -1 over -1/5, it's kind of just like this right in here. That would be the same as negative, I'll do it over here at the side. If you had 1 over -1/5, that would be the same as 1 divided by -1/5. That would be 1 times -5 over 1. That would be -5. And so the opposite of -5 becomes just 5. So we wound up kind of going through and getting back to just a 5 when we got finished. Okay. All right. And then we might be asked to compose two functions and come up with a rule that still winds up having an x in it. Just do it in general rather than for these specific cases. So if you're asked to do g of f of x, you just follow the directions. Start with your input and do the f function. The f function would be square root of x plus 2. Then you need to do g of that. And g says do -1 over your input. Okay, -1 over the square root of x plus 2. Really, I like it like that. But again, you might sometimes see it go on and rationalize the denominator because you probably were harped on to not leave radicals in the denominator. I really like this, but if we did rationalize it, it would have the negative square root of x plus 2 on top and then just x plus 2 on the bottom. Okay, because you would have multiplied by the square root of x plus 2 top and bottom. Okay, all right, but to me that doesn't make it easier. Okay, so you could do either of those. All right, now for g of x, we just follow the directions. We start with x, and we're going to run it through the g function, which says do -1 over your input. So we do that again. G function is -1 over your input. Now we've done that several times, that type of work. So that means -1 divided by -1 over x. -1 times x over -1. Negative times negative is positive x. We would just get x for our final rule. Okay. All right, now let's look at the domain for each of these. For these new functions we're creating, if we wanted the domain, how to think about it. All right, when you're trying to do the domain on these, you kind of have to think about the order in which you go through them. Okay, so here the f was first, the g was second. Here it's like we did the g function once, but then we did it again. Okay, so that's going to come into play when we're kind of analyzing the domains. So what most people do on these is they just look at the n format here. They look here and they look at what's the issue with that. So they think it through like this. G of f of x at the end turned out to be -1 over the square root of x plus 2. Okay. All right. So I like to look at it from here, not the green version, because here I can tell that x plus 2 is under the radical, so it better be bigger than or equal to 0. So I know that my x better be bigger than or equal to 0, or it's not going to get through the radical. And that was what the f function was. The f of x was square root of x plus 2. Okay. All right, but here's the deal. The g function wound up having me then take the square root of x plus 2 and do, the g function was this. Okay. So when I put in the square root of x plus 2, I created the denominator. See how now the radical is in the denominator? So really that x can't be negative 2, otherwise your denominator would be 0. Okay? And so what you typically do on these is you look at the overall simplified result and you analyze it. And you see the radical, and then you see the radical is in the denominator. So ultimately the domain is going to be that x has to be bigger than negative 2. Turns out it can't be equal to it, or you would have a denominator of 0. So you would say the domain is from negative 2 to infinity, can't be the negative 2. That's the domain. Okay. All right. Now, sometimes the issues are hidden from you. So if you look at this one, g of x, write that in red like I did on the other one. I like it to match. So g of x, we worked out and we got x. If you look at that, it seems like any real number you plug in is going to give you a real number coming out. Okay, so at the very end, after you went through all this other stuff, down here at the end of the whole thing, an x came out and it looks like there's no trouble spots. You really have to go back and look at the first function. So when you're doing domain, you can look at the ending rule. I don't see any trouble spots, but then I have to go back here because x started out going in there into the g function. And the g function said to do negative 1 over your input. And so for this one, we know x better not be 0 or I'm not going to get out of the g function. I'm not going to have something defined. And so even though you don't see it up here, the domain on this one is all real numbers except 0. And you would have missed this issue if you didn't think about how those functions are stacked and how there could have been an issue getting through that first function that just got hidden from you. Because when you simplified, it ultimately turned out not having a denominator. Okay. All right. So that's kind of the intro to what combinations are. And I did the section of it that dealt with the equations. And then I'll come back and I'll look at combinations from tables and graphs.